Hi everyone, we're going to pick up with section 1.3 and 1.4 and really get into the heart of what exactly the trig functions are and what they represent, both in this section and then as we get into 1.4 doing a little bit of application with that as well. In right triangles, which is pretty much what we're going to be talking about for most of the course, we're going to do right triangles from this chapter all the way through the end of chapter 6. Once we get into chapter 7, we'll see what happens with other triangles, but for right now we're going to stick with right triangles. Capital letters represent the angles, and the lowercase letters usually represent the sides. And sides are always across from their angles that they represent. So for instance, if you were to draw a right triangle, you'll have to pretend like that with a straight line because I'm not a very good artist. Your angle A would be here, whereas side A would be across from it. Angle B might be up here, with side B across from it, and side C, which is usually the hypotenuse, is usually across from side C, which is the right angle. So that's usually our representation that we will use. There are 6 trig functions. If you didn't know that, now you know there are actually 6. Most calculators have 3, and those are sine, cosine, and tangent. But there's also secant, cosecant, and cotangent. And we can define these trig functions actually 3 different ways. And the first way that we're going to talk about is in this section, whereas we draw a line, or a ray actually, this right here, this ray, going through this point P. So this point P, maybe I might make it a different color. We might make it green. There's my point P. And that point P has a x coordinate and a y coordinate that give you that location. The point itself would make a triangle. So we would have a vertical side and a horizontal side based on the length of the triangle. On the bottom would be x, the height would be y, and we have a distance r that would go out from the origin through that point. Based on those 3 sides, then we can come up with this ratios of what sine and cosine are. So our angle theta that we're talking about here is actually right here. This is angle theta. And angle theta gives you sine, cosine, tangent. So sine is the y over the r, cosine is the x over the r, and the tangent is the y over the x. Then we could flip those upside down and say that cosecant is r over y, secant is r over x, and cotangent is x over y. Notice the 3 that are on top, these 3 right here that are on top, just get flipped over to be these 3 here on the bottom. The x and the y could be either positive or negative, but the r is always positive, always positive. And you can find r just by doing the distance formula from algebra and do the square root of x squared plus y squared. It's also the Pythagorean theorem, if you know the Pythagorean theorem, for x squared plus y squared equals r squared. You just take the square root of the r squared to get the r. And so those are the formulas we're going to be working with in this section. So now we're going to apply those definitions in a problem. So this one says graph the angle and find the values of the 6 trig functions. So I'm going to start with the graph itself. Looking at the point -4, -3, that tells me to go over to -4 and then down to -3. So I have a point somewhere about right here. And so my angle would just be the line that goes through that point. And sometimes if you miss the point, just make the point a little bit bigger. You'll hit it eventually. And so the angle itself, remember your angles always start on your positive x-axis. So if we're going around this way, we're looking at an angle that looks like that. But we do have a triangle that's drawn. If you want to kind of look at the triangle way that we were looking at on that previous slide, I would have a vertical side and a horizontal side, and then the r like that. So the x would be -4. That tells you to go to the left 4, and the -3 tells you to go down 3. So put the wrong one on there. -4 is the horizontal side. So that goes there, and -3 goes on that side. And then we can find the r by doing our formula. Usually r is not given. Some of you might notice this is going to end up being a 3, 4, 5 triangle, and if you do, that is great. If you don't, you can always do the formula, the -4 squared plus the -3 squared. So that'll give me 16 plus 9, or square root of 25, which is 5. So this diagonal is 5, or hypotenuse, if you will. Once you get the triangle drawn, with all the sides solved for, we then just write down the answers. Sine is the y over the r. So y is -3, and the r is 5. Cosine is the x over the r. So that would be -4 over 5. And tangent is y divided by x. So the y value is -3, the x value is -4. So when you divide them, you actually get +3 over 4. The cosecant, secant, and cotangent is just flipping over the sine, cosine, and tangent. And so I would get -5 thirds, -5 over 4, and +4 thirds. And that's all 6 trig functions, fairly easily to do. Hopefully that makes sense. Let's try another one, except for here, one of our numbers is 0. So we're going to have the point -3, 0. If I was to plot that, -3, 0 is just 1, 2, 3 to the left, and I don't go up or down any. So my angle itself, this would be my point right here, but my angle goes along the axis. And you might remember what we talked about in the last video. All your angles that end up on your axes are your quadrantal angles. So this is actually a straight line compared with the positive x-axis. I could tell you automatically this angle is 180 degrees. Now, one downside to that is you do not end up with an r value in this case. The reason is because, well, you kind of end up with an r value, but because of you're not making a triangle out of it. If you tried to do the r ends up being the x squared and then the y squared. So all you're going to end up with just square root of 9, which is 3. So if you're on an axis, you're not going to have a diagonal. All you're going to get is the absolute value of whatever number you had other than 0. So here we have -3, 0. So we're going to get the absolute value of -3, which is 3. We can still use our definitions. It's just that sometimes, because of that 0, we're going to get some things that won't work out very well. So your sine is y over r. Well, the sine is y being 0, and the r would be 3, so you get 0. And you can actually test this one in the calculator if you want to. If you pulled your calculator out, typed in sine of 180 degrees, it should give you exactly 0. If you do cosine, that is x over r. So I'll get -3 over 3, which is actually -1. And again, you could do that in the calculator. If you typed in cosine of 180 degrees, it should give you exactly -1. And tangent is y over x. So I get 0 over -3, which is 0. Again, you could type that in the calculator. Now, because 2 of the 3 come out to be 0, and the other trig functions are reciprocals of that, then you're going to get some things that are not defined. So like sine equals 0, cosecant is what you get when you flip over sine. If you flip over 0, you'll get a 0 in the denominator. That's undefined. Or I'm going to put D and E for does not exist. If you flip over -1, you still get -1. And if you flip over 0, you'll also get something that does not exist. And so there's a few times along the way that, especially on the quadrantal angles, that you're going to get things that do not exist. And they're usually one of the secant, cosecant, and cotangent ones. Okay, let's try another one that doesn't have a 0 in it. This is the point 1 and square root of 3. So 1 will just go over 1. Square root of 3, that would be one of those things that, a lot of people don't know what the square root of 3 is right off the top of their head. But you can type it in the calculator. It's a little more than 1.7. It's about 1.73-ish or so. So if I go over 1 and up about 1.7, I'm about right here. And so my angle, ooh, that one actually looked kind of good. So there's my angle theta. This will make a triangle. Maybe I should have made it a little bit bigger, but there's a triangle sitting here that we can find the r for. The side is a 1. The height is the root 3. And so the right hand, the hypotenuse here, we can find fairly easily. If you did a lot of stuff in geometry, and you remember a lot of stuff from geometry in high school, then you might notice that this is a special type of triangle. We'll get 1, oops, let's square it off there, 1 plus 3. Square root of 3 and 1 gives you the 4, and square root of 4 is 2. This has a diagonal of 2. This is actually a 1, 2, root 3 triangle, or you may have heard of a 30, 60, 90 triangle. That's what this triangle is. But using those values, then we just write down our answers. Sine is y over r. Cosine is x over r. Tangent is y over x, or just square root of 3. And the rest of them, you flip them over. So when you flip over 1/2, it's pretty easy to get 2 over 1, which is just 2. When you flip over the rest of them, they'll probably ask you to rationalize it. So if you flip it over, you just get 2 over root 3, flipping sine to get cosecant. But the little trick, if you don't know this trick, this is how you do rationalizing without actually working it out. You take the number on the bottom, the root 3, move it up to the 2 on top, and make it 2 root 3. And then you drop the radical sign off on the bottom. So it's 2 root 3 over 3. Or if you flip over the 1 over root 3 from the root 3, if I want to rationalize it, I move the root 3 onto the top with the 1. So you get 1 times root 3, which is just root 3. And drop the radical off on the bottom. And that's all 6 trig functions pretty quickly. Okay, this says given a quadrant and given a ratio, can you determine whether the ratio is positive or negative? This will come up a little bit more, especially once we get into, say, chapter 3, but kind of an introduction of kind of where we're heading to. So quadrant 4, you might remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So we're in quadrant 4 down here. And we have a y over an x. So everything in quadrant 4 will have a positive x because you're going this direction. That is a positive x, but you got to go down to get into quadrant 4. That is a negative y. So you're dividing a negative on the y by a positive on the x. So quadrant 4, if you divide y over x, that should be negative, because a negative divided by a positive is a negative. Now you might also notice y over x is what we call tangent. That's tangent of an angle, is y over x. Which means if you pick any angle that ends up in quadrant 4, every tangent value would have to be negative. If we look at part B, quadrant 2 would actually be this quadrant up here. And we would have, to get into that quadrant, you'd have to have a negative on the x's and a positive on the y's. Again, you're dividing x over y, so x would be negative, y would be positive. This would also be negative. You might also notice x over y is cotangent. So that means that any angle that ends up in quadrant 2, the cotangent of that angle has to be negative. And then the last one, if you're starting with quadrant 1 is this angle here. To get into quadrant 1, you have to go positive with the x's, and you have to go positive on the y's. Here, we also have the r thrown in there. We're looking at r over x. But remember, r is always positive. So you have an always positive number divided by x's, which are also positive. This has to be positive. R over x is actually secant, which means secant would be positive in quadrant 1. And you can kind of rationalize in your head, because your x's are positive, your y's are positive, and your r's are always positive. It doesn't matter how you divide them, you'll always get a positive answer. And so that actually means that all 6 trig functions are positive in quadrant 1. And we'll come back to that idea. So this says, given the equation of the terminal side of an angle, find the values of all 6 trig functions. So this is a little bit of college algebra per se. We're looking at sketching really this line, 2x plus y equals 0, where x is greater than 0. I have come to the realization in the past that a lot of people like to take this equation and solve it for y and make it y equals negative 2x, where x is greater than or equal to 0. Which means you can just plot points if you want to, or you might notice that the negative 2 is the slope of the line. So it has to go through 0, 0. And then negative 2 would tell you to go down 2 and over 1. Since its x is greater than 0, then we're only going to go this direction with it. And again, pretend that's a straight line. So that's the terminal side of the angle. Your angle would actually go all the way around this way if you're doing it in a positive direction. And we're asked to find the 6 different trig values. Well, you need a point for the x and the y, and then you need the r. So the point here, this is the point, negative 1. Oh, sorry, not negative 1, positive 1, negative 2. You went over to the right and down 2. And then I could find the r based on that. My r value would be the square root of 1 squared plus negative 2 squared. So I'm going to get square root of 5. Again, remember, r is always positive. If you would like to draw the actual triangle we've been talking about here, kind of looks like that. And sine would just be start dividing things. Y over r, then x over r for cosine. So sine is y over r, so I get negative 2 over root 5. Or if you rationalize it, pull the radical up to the top and drop the radical side off on the bottom. Cosine would be the x over the r, or pull the radical up to the top and drop the radical sign off on the bottom. So you get square root of 5 over 5. Tangent is the y over the x, so that's negative 2 over 1, which is negative 2. Here's a little thing you might notice, and this pops up a little bit in calculus. Notice that the slope of our line down here is actually the same thing as your tangent value. That is not a coincidence, by the way. Cosecant is what you get when you flip over a sine. If you're going to flip one over, flip the one that you flip the one before you rationalized it. So don't flip the negative 2 root 5 over 5. Flip the one before that and get negative root 5 over 2, so you don't have to rationalize it again. Or 1 over root 5 just becomes root 5, or negative 2 becomes negative 1/2. And that's all 6 trig functions based on that line of the terminal side. Okay, this says find the values of the trig functions of the quadrantal angles. The easiest thing for you to do here is to pull out your calculator and type them in. There is a more hands-on approach to do this as well that we will get to, but at the moment the easiest thing would be to type them in. What will happen is if you work them out by hand at this moment, you would have to notice, like for instance, I'll show you the first one just for fun. You'd have to notice that you're 90 degrees. 90 is up here. And so your angle makes this right angle on the axis. So you'd have to have a point on that line. Like for instance, you could use the point 0, 1. It wouldn't matter which point you used, you just needed a point. And then once you take that one point, you know cosine is x over r, so you could find the r by doing the square root of 0 squared plus 1 squared. That's a squared, by the way. So you get the square root of 1 squared, which is just 1. And cosine would be the x over the r. Your x value is 0, so you'd have 0 over 1, which is 0. And you could do that on every one of these problems. But, especially since this is an online portion here anyway, I would suggest that the quicker, easier way would be to take out a calculator, type in tangent of 180 degrees, and it'll spit out the number 0. Or type in, now some calculators do not have secant. And so since you don't have secant on the calculator, you have to notice that secant and cosine are reciprocals of each other. So you actually type in what is cosine 180, which would be negative 1. Flip that over to get negative 1. So you got to flip it to get that part. But sine, cosine, and tangent are all on the calculator. So if you type in sine of negative 270, that's no problem to do. You'll actually get 1. Or secant of 1800, again, I would type in cosine 1800 in the calculator. It will come out to be 1, I believe. And so we would flip that over to get the correct answer for secant. Which would be 1. And again, it doesn't look like it's doing it, but I'm actually flipping that over to get to secant. But on those, the easier thing would be just type it in the calculator. Okay, these would do the same sorts of things. You can type them in the calculator if you want to. If you do, I would suggest doing each one individually. Cosine of 90, typing this into the calculator, this part right here is just 0. Sine of 270, ignore the squared when you type it in the calculator though. So type in sine of 270, you'll get 1, and then that 1 gets squared. So this is just 3 times 1, which is 3. Or on the next one, tangent 360, just this part right here, if you type that in the calculator, you'll get 0. If you type in just sine of 180, you'll get 0. And again, ignore the squared, but if you type in cosine of 180, you'll get 1 squared, which is 1, times 5 makes 5. And like on the other ones that we said a moment ago, secant 180, you don't have a secant on a calculator for most people. So you would type in cosine 180 and flip it. Cosine of 180 is 1, so if you flip it over, you'll get 1. Sine of 360 is 0, and that gets squared. And then cosine of 180 is negative 1. So this ends up being, technically secant 180 is actually negative 1 squared, but it still comes out to be 1. So I get 1 minus 0 minus 1, which is 0. Now, if you're really good at typing stuff in the calculator, you could type in the entire thing all at once. You just have to be careful with the squares and things. So hopefully that makes sense. All right, let's go into 1.4, which is we're going to use these definitions in a few different word type problems. We did mention that sine flipping over becomes cosecant, secant flipping over becomes cosine, and all of those things. There's actually what we call reciprocal identities for that. We've already been doing it. We did it in the last section. This is just kind of a formalized definition that if you want to know what sine is, you could flip over cosecant. If you want to know what cosecant is, you could flip over sine, and so on for all 6 trig functions. So if they were to ask you a problem like find the function value using the reciprocal identity, all they want you to notice is that you can flip each one of them over. Find cosecant if you know sine is -2/5. Well, since cosecant and sine are reciprocals, all I gotta do is flip it over and make it -5/2. And that's all you do. Or find cotangent if you know tangent's equal to 4. Well, cotangent is tangent flipped over, so I would just flip over 4 to make it to be 1/4. Now, the ones with the decimals are a little bit harder to do, and you'll probably have to do that on a calculator because not many people would know what that would be. So, like for instance, if it says find sine given cosecant this decimal number, well, sine is cosecant flipped over, so I have to take 1 divided by 2.56158.4, pull out the handy dandy calculator, and I'm doing it along with you all if you're wanting to follow along. I'm actually typing it in the calculator right now. So 1 divided by that gives you 0.3903383. I'll try to go the same amount of decimals anyway that the original problem had. Be careful on the homework though. They will ask you to round to various different things. It might say round to 6 decimals, 7 decimals, 5 decimals. So if you don't round it correctly, it won't give you credit for it. So be real careful on that. Okay, this is called the ASTC chart. And we've kind of hinted at it a little bit in the last section as well. The ASTC chart tells you what quadrants the trig functions and their reciprocals are positive in. And that's why it's called the ASTC chart, because in quadrant 1 they're all positive. In quadrant 2, sine is positive. That's where the A and the S come from. Quadrant 3, that's the T for tangent, and C for cosine. So all sine, tangent, cosine. So that's why it's the ASTC chart. Their reciprocals are also positive because they are just reciprocals. So sine and cosecant are actually both positive in quadrant 2. Tangent and cotangent are both positive in quadrant 3. And cosine and secant are both positive in quadrant 4. And there's a few different ways you can remember this using different naming remembrances. ASTC, you could do it just as all sine, tangent, cosine. That one doesn't really flow off the tongue very well. Most people do things like all students take classes for the ASTC. Or you may have also heard all students take calculus. I don't like doing the all students take calculus because not every student at Mississippi State would take calculus, but every student takes classes. There's also one that's a little bit racier. All strippers take cash is also applicable. And as far as I know, is always true. I think all strippers do take cash, though I have no personal experience with that. But It's another one to, and I have found in the past most people like the all strippers take cash better because it's just easier to remember. I'm not sure why. But anyway, you'll need to know this, and we'll be building on this chart as we go along, adding more stuff to it. One other thing you might want to notice is the angles are not on here, but this right here, if you put your quadrantal angles on there, this is 0 degrees. Then you go up to 90. This goes over to 180. This goes down to 270. And then it goes back over to 360. So quadrant 1 is anything between 0 and 90. Quadrant 2 is anything between 90 and 180. Then 180 to 270 for quadrant 3. 270 to 360 will get you to quadrant 4. So when it says determine which trig functions will be positive given an angle listed below, they're wanting you to apply that idea from that ASTC chart. So if you have this ASTC, and you have the angles going from 0 to 90, 180 to 270, back to 360, then 150 is between 90 and 180. And so since 150 is between 90 and 180, this angle is in quadrant 2. And in quadrant 2, the only trig functions that are positive in quadrant 2 are sine and cosecant. Now sometimes your angles aren't in the right format, I guess. They give you a coterminal angle that's not on the chart, like negative 36. Negative 36 is not between 0 and 360. So, because of that, you have to add 360 to it to get it to the correct format. So if I was to add 360 to this angle, I would end up at 324. 324 is in quadrant 4. And quadrant 4, since it's between 270 and 360, that is where cosine is positive. So cosine and its reciprocal secant is positive. Now, 845 is too big. So it's not between 0 and 360. It's just gone around too many times. So we actually have to subtract off 360 actually twice here. So if you subtract it off twice, you'll end up with an angle of 125 degrees. That is in quadrant 2. So just like the part A, that would be sine and its reciprocal cosecant. Both of those are positive in quadrant 2. Okay, this is kind of going the other way around. They give you two different trig functions and ask you where that would actually be at, what quadrant it would be in. Identify the quadrant where both sine and cosecant are positive. So what I would do here is draw your little ASTC chart. The first trig function eliminates two quadrants. The other one may eliminate a third. It doesn't have to. So you could have one or two answers. This first one says that sine is greater than 0. So it can't be in quadrant 3, and it can't be in quadrant 4, because sine is not positive there. Sine is positive where they're all positive in quadrant 1, and it's also positive in quadrant 2, because that's what the S is for. Cosecant actually has the same quadrants, because they're reciprocals. So in this case, this actually ends up being two answers, quadrant 1 and quadrant 2. Both quadrant 1 and quadrant 2 would give you a positive sine, which in turn, since it's reciprocal, give you a positive cosecant. Okay. On the second one, cosine is positive. Well, cosine is positive, that eliminates quadrant 2 and quadrant 3. Cosine's positive where they're all positive in quadrant 1 and also in quadrant 4. The second part says you also need sine to be positive. Well, sine is not positive in quadrant 4, so that eliminates quadrant 4. And so the only possibility we have here is the only quadrant where both sine and cosine are positive is quadrant 1. And then one more, if tangent is positive, tangent positive eliminates quadrants number 2 and number 4. Tangent's positive where everything is positive in quadrant 1 and also positive in quadrant 3. That's what the T is for. And then the other option, or the other part of it, says, okay, what about cosine being negative? Well, cosine being negative eliminates quadrant 1 because it can't be where they're all positive. And that only leaves you with quadrant 3 as an option. And it'll be important as we go along to make sure that we're in the correct quadrant when we're coming up with our different trig function values. Just like in algebra, you could talk about domain and range. This book, for some reason, puts range in this chapter, and we don't talk about domain until chapter 4. And so I'm not sure why, but anyway, I'll tell you what range is about. The range is what possible outputs you could have. Sine and cosine are bounded. You cannot have anything equal to sine or cosine that is bigger than 1 or less than negative 1. You have to have some sort of decimal or fraction between negative 1 and 1. Secant and cosecant are the opposite. They can be anything else except for what's between negative 1 and 1. And tangent and cotangent, they're the laid-back trig functions. They could be equal to anything, and they don't care. So you'll get a few problems that just ask things like, is this possible? Like, for instance, is this possible? Can you have sine theta be equal to 2? And the answer is no, this is not possible. The reason is because sine theta has to have values between negative 1 and 1. It can't be equal to 2. Cosine theta equals negative 0.96. This one is possible. For the same reason, cosine has to be between negative 1 and 1. And 0.96 or negative 0.96 is between negative 1 and 1. The secant theta being negative 0.3, that is not possible. Secant and cosecant cannot be between negative 1 and 1. So you have to go either less than negative 1 or bigger than positive 1. Since that negative 0.3 is between negative 1 and 1, that's not going to be possible. Okay, this says find the value for each of the variables. For each variable, there's only one variable in there. Tangent of 3 theta minus 4 degrees equals 1 over cotangent of 5 theta minus 8. Now these two functions are reciprocals of each other. So what you could do is 1 divided by cotangent is the same thing as tangent. So you could rewrite this to be tangent 3 theta minus 4 equals tangent 5 theta minus 8. And if they both have tangent on there, then neither one need tangent. You just set the stuff on the inside equal to each other. 3 theta minus 4 equals 5 theta minus 8. And do a little bit of algebra. You subtract the 3 theta from both sides and you add the 8 degrees to both sides. I'll end up with 4 degrees equals 2 theta. And divide both sides by 2. So theta is 2 degrees. And by the way, on the homework and things, they usually don't want you to put the degree symbol on there. Just putting in the number 2 would be fine. So we'll do one more of those. The idea here is you want to get the trig functions to say the same thing. That way you can drop them off. So sine theta, or sine of 4 theta plus 2 degrees times cosecant of 3 theta plus 5 degrees equals 1. What I could do is I could divide both sides by cosecant 3 theta plus 5 and make this a sine, oops, made a little mistake there, sine of 4 theta, oops, there's no degree symbol up there, 4 theta plus 2 degrees equals 1 divided by cosecant of 3 theta minus 5 degrees. No, sorry, plus 5 degrees. Don't want to mess that up. And since 1 over cosecant is the same thing as sine, then I can make this say sine of 4 theta plus 2 degrees is actually the same thing as sine of 3 theta plus 5 degrees. Since they say the same thing, you can drop the sign off and just say that 4 theta plus 2 equals 3 theta plus 5. And again, do a little bit of algebra. We would subtract the 3 theta from both sides. And we could subtract the 2 degrees from both sides. And 4 minus 3 just gives you 1 theta, and 5 minus 2 is 3 degrees. And that would be your answer. And that's the end of chapter 1. Hopefully that's not too bad. And if you have questions, you let me know. And then we'll start chapter 2 right after this.